In this video, I will demonstrate how to solve rational inequalities. A rational inequality is an inequality of the form f of x is greater than 0, f of x is less than 0, f of x is greater than or equal to 0, or f of x is less than or equal to 0, where f of x is a rational function. Solving rational inequalities is very similar to solving polynomial inequalities. The only difference is that we also need to determine the restrictions on the variable of a rational function. Since these values are not in the domain of a rational function, they cannot be in the solution set of a rational inequality. Steps to solve a rational inequality are very similar to what we've seen with the polynomial inequalities. We first rewrite it so that one side is 0. And then we want to find the zeros of the function by solving the equation f of x equals 0. Also, we find the restrictions on the variable, that is, the values that make the denominator 0. Again, these numbers are called boundary numbers. We want to then determine the sign of the function at intervals around the zeros and restrictions by evaluating the function at a test point in each interval, or by using the graph of the function. Then we want to determine which intervals satisfy the inequality, determine if the zeros are included in the solution set. The restrictions on the variable will never be included in the solution set. Then we want to write the solution set of the inequality in interval notation. Now, when we want to determine the sign of the function at intervals around the zeros, it might be helpful to draw a number line and place your zeros and restrictions on that number line so you're clear as to which intervals you need to test. Here's an example. We want to solve the inequality 1 divided by x plus 4 is less than or equal to 2. So we set 1 divided by x plus 4 minus 2 is less than or equal to 0. We need to find our zeros of the function and also the restrictions. The restriction is found by setting x plus 4 equal to 0, right, the denominator equal to 0. So that is x equals negative 4. To find the zeros, we're going to solve the equation 1 divided by x plus 4 minus 2 is equal to 0. We multiply everything by the LCD of x plus 4. That results in 1 minus 2x minus 8 equals 0. Be sure to distribute the negative 2 to that LCD. Combining like terms, we get negative 2x minus 7 equals 0. Negative 2x equals 7, or x is negative 7 divided by 2. And if you need to put that as a decimal so you can think about the values in the intervals, you can. That's really a negative 3.5. So thinking about the intervals that we need to test, we have a negative 3.5 and a negative 4. Negative 4 is to the left of negative 3.5. So the intervals that we have to test are from negative infinity to negative 4, negative 4 to negative 3.5, and then negative 3.5 to infinity. And again, we can label those as A, B, and C. So our test point to the left of negative 4, we might use negative 5. Between negative 4 and negative 3.5, maybe negative 3.7. And then 0 is to the right of negative 3.5, so we'll definitely use that. And then when we replace the variable with these values, we want to determine if the function value is positive, negative, or so on. So our function value, when we substitute negative 5, we get 1 divided by negative 5 plus 4 minus 2. And so what is that? 1 divided by negative 1, which is negative 1 minus 2, which is negative 3. Then 1 divided by negative 3.7 plus 4 minus 2 is going to be 1 divided by 0.3 minus 2, which will be 1.33. And then when we replace x with 0, we get 1 divided by 0 plus 4 minus 2, so that's 0.25 minus 2, or negative 1.75. So a few ways you can do this. I see that the function value is negative, positive, and then negative. And I'm trying to figure out where my function is, right, less than or equal to 0. So I want the function value to be negative or 0. And that happens in intervals A and C. Or you can also ask yourself, is negative 3 less than or equal to 0? Yes, that satisfies it. That's true. Is 1.33 less than or equal to 0? No, that does not satisfy that inequality. Is negative 1.75 less than or equal to 0? Yes, that is true. Now, can we include our endpoints? Well, negative 4 is a restriction. It can never ever be included, so we always have to put a parenthesis on that. Negative 3.5 is a 0. We are permitted to include where it's equal to 0, and so we can put a bracket on the negative 3.5. So our solution set would be negative infinity to negative 4, union bracket, negative 3.5, or if you want to be precise, negative 7 halves to infinity. Now, we could have also used the graph, right? We know the graph of 1 over x. And so if we have 1 divided by x plus 4 minus 2, right, if that's our function we're graphing, it's going to shift left 4 units, so our vertical asymptote is going to shift left 4. And our horizontal asymptote is going to shift down 2 units. So y equals negative 2 is a horizontal asymptote. X equals negative 4 is the vertical asymptote. We know it's equal to 0 at negative 3.5. It's going to be hard to show there, but we also know the end behavior around those values. Right, there was not a reflection, so it's going to have that same basic shape of 1 over x. And then look, we're trying to find where the function is negative, right? And it's negative to the left of negative 4 and also to the right of the negative 3.5. And that's exactly what we found when we tested actual points.